Rolle's theorem states that if we have a function f that is continuous on a closed interval ab and it's differentiable on the open interval ab with the endpoint values f of a and f of b being equal, then there is a point c between a and b at which the derivative of the function f prime of c is 0. So the intuition behind Rolle's theorem is this: if we have a function that is continuous on a closed interval between a and b, and is differentiable for every point between a and b, and has the same endpoint values, then there will be at least one point between a and b called c, where the tangent line is horizontal, the slope of the tangent line, the derivative at that point is 0. Now, all of the conditions in the theorem are crucial and necessary. For example, if f is continuous on only an open interval, you could imagine having something like this. So this function that I'm going to draw is going to be continuous on the open interval ab. So let me draw it like this. It has the same endpoint values and is differentiable for all points between a and b, but because it's not continuous on a closed interval, Rolle's theorem does not apply, and you can see that there is no point at which the derivative would be 0. Differentiability is also important on the open interval ab. For this, consider the absolute value of x. On the closed interval -2, between -2 and 2, it is continuous. On the open interval between -2 and 2, it is not differentiable everywhere because the derivative at 0 does not exist. And even though the endpoint values are the same, there is no point between -2 and 2 at which the derivative would be 0 for this function. And finally, to have the same endpoint values is also important, because you could just remove this discontinuity for this function, make it continuous on the closed interval between a and b, and differentiable on the open interval between a and b. But because the endpoint values are not the same, it's possible that there won't be any points between a and b at which the derivative would be 0. Okay, let's see if you got the idea. Confirm that the function f of x equals the cosine of 4x meets the criteria of Rolle's theorem over the closed interval between 0 and pi over 2, and find all numbers c that are in the conclusion of Rolle's theorem for this function. Pause the video and select your answers now. Okay, I hope you pause it, and I've selected c equals pi over 4. So let's check the criteria first. The cosine of 4x is continuous everywhere, so it is continuous on the closed interval between 0 and pi over 2 as well. It is differentiable everywhere, so it is differentiable on the open interval between 0 and pi over 2 as well. Its derivative, as you know, is the sine function. More precisely, it's minus 4 times the sine of 4x. Now, the endpoint values of the function on this closed interval between 0 and pi over 2 are also equal. They are both 1, being the cosine of 0 and the cosine of 2 pi. So Rolle's theorem applies to this function, and indeed there is a number between 0 and pi over 2 where this derivative, negative 4 times the sine of 4x, vanishes, and that is exactly at pi over 4 in that open interval between 0 and pi over 2. The problem with all the other options is that they are outside that open interval between 0 and pi over 2. Let's look at the next question. Consider the function f of x equals x to the 2/3 plus 3, and show that the endpoint values on the closed interval between -1 and 1 are the same, but there is no number c between -1 and 1 such that the derivative of the function at that point would be 0. So is it true or false that this contradicts Rolle's theorem? Pause the video and select your answer now. Okay, I hope you paused it and have realized that this does not contradict Rolle's theorem. So first, let's check that the endpoint values are indeed the same. So f of -1 is -1 to the 2/3 plus 3. Well, to the 2/3 means that we are taking the cube root of the square of -1, and that is the cube root of 1, that is 1 plus 3, so we get 4. And similarly, f of 1 is the cube root of the square of 1 plus 3, so we get 1 plus 3, that is 4. So indeed, the endpoint values are the same. The function is continuous between -1 and 1 on the closed interval, but it is not differentiable at every point between -1 and 1. Namely, at 0, the derivative of this function does not exist. Every other place, the derivative of this function, as you may know by the power rule, is 2/3 times x to the -1/3. So that is 2/3 times 1 over the cube root of x. At x equals 0, this does not exist, is not defined. So Rolle's theorem does not apply to this function f of x. Therefore, there is no it is not guaranteed that there is a point at which the derivative would be 0. And indeed, if you look at this derivative function between -1 and 1, where it is defined, it's never 0. Okay, I hope you enjoyed this video, and I'll see you in the next one.